Good day. Today we'll be focusing on the equation of tangent and the equation of the normal. So we know that we're looking at derivatives again. So here's our first example. So y is equal to x squared minus 4 and x is equal to 1. Okay, so first we have to find our gradient. So finding our gradient, we apply derivatives because we know that the change in y and change in x represents our gradient. So dy by dx is equal to, when we find the derivative of that, we know that it is 2x. Now we have our x value there, so dy by dx is equal to 2 times 1. So dy by dx is equal to 2. Now, to find the equation of the tangent, we know that we have a straight line here, and the equation of a straight line is y equal is in the form y equal mx plus c. So from there we can go ahead to find our equation of the tangent, knowing that we have our gradient. But firstly, we need a corresponding y value so that we can plug in our values and find our intercept. So we're going to use back the original equation to find our corresponding y value for x value, which is 1. So y equal x squared minus 4, y is equal to x, which is 1 squared minus 4. Y is equal to 1 minus 4, therefore y is equal to minus 3. So when x is equal to 1, y is therefore equal to minus 3. Now we can go ahead and find our equation. So minus 3 is equal to m, our gradient here, 2 times 1 plus c. So minus 3 is equal to 2 plus c. C is therefore equal to minus 5. So the equation of the tangent is equal to, y is equal to, our gradient there, 2x minus 5. Now we know that the normal is perpendicular to the tangent. Therefore, going back to our rules, we know that the gradient of a line perpendicular to another, their product is equal to -1. So if our gradient is 2 here for the equation of the tangent, therefore for the equation of the normal, our gradient should be equal to, we have 2 times x is equal to minus 1. So we have x is therefore equal to minus a half. So our gradient to find the equation of the normal is a half. So m is equal to negative a half, for the, and we're going to use that to find the equation of the normal. So we now have y still in the form y equal mx plus c. So we have y being minus 3 is equal to minus a half, or x value 1 plus c. So minus 3 plus a half is equal to c. So that means c is therefore negative 2.5, 2.5 rather, minus 2.5. Let's keep it in fractions. So the equation, so therefore equation of the normal is y is equal to our gradient minus a half x minus 2.5. Here we have another example. So now, first again, we find our derivative. So dy by dx is equal to 2x minus 5. Now dy by dx Our x value is 2, so we plug in our x value. 2 times 2 minus 5, so we put dy by dx equals 4 minus 5 minus 1. Now we're going to find our corresponding y values. So we have here we have another example. Remember, feel free to pause the video and try it. Your solutions are here. So first we find our derivative, so that is dy by dx, and we know that 2 times 1, so that is 2, and 1 from 2 remainder 1. We don't have to write that, so we end up with 2x minus 5 for our derivative. Now using our x value, we have our gradient becoming dy by dx 2 times 2 minus 5 dy by dx. 4 minus 5, we have minus 1. Alright, so now we're going to find our corresponding y value for our x value. So we have y is equal to x squared minus 5x plus 7. Y is equal to 2 squared minus 5 times 2 plus 7. Y is equal to 4 minus 10 plus 7. Y is therefore equal to 1. So when x equal to, y is equal to 1. Now we're going to find our equation of the tangent. So equation of tangent we have y is equal to mx plus c. Equation of straight line. Hope you don't ever forget this. This is life. So our y value is 1. Our gradient here is minus 1. Our x value is 2 plus c. So 1 is equal to minus 2 plus c. C is therefore equal to 3. So our equation of tangent therefore is y is equal to our gradient minus 1. So you have negative x plus 3. Alright, now moving on, we're going to find the equation of the normal. So let me write this on over here. Equation of normal, still in the form y equal mx plus c. If you don't remember, just write it as to never get confused. Okay, now remember that the gradient of the tangent times the gradient of the normal should always be equal to minus 1, seeing that they are perpendicular to each other. So the gradient of the tangent is minus 1, therefore the gradient at the normal is going to be 1, or y value is 1 is equal to 1, or x value is 2 plus c. So we have 1 is equal to 2 plus c. C is therefore equal to minus 1, so we can go ahead and write our equation of the normal. Therefore y is equal to or gradient 1, so x minus 1. Very simple, right? Alright, so here we have another example. Y is equal to x minus 2 by x squared minus 1 when x is equal to negative 2. Alright, good. Remember, feel free to pause the video. Nothing beats a trial than a failure, and your solution is here. So no need to worry. Just go ahead, try, and then you come back and play and check to see if your answer is correct. Okay? Alright, now we're going to find our derivative, but we realize that we can't just apply the normal derivative rule here. We have to use our product rule. And our product rule states f prime of x, g of x, plus g prime of x, f of x is equal to or derivative dy by dx. So now we can go ahead and let f of x equal to x minus 2, f prime of x or derivative is equal to 1, g of x equal x squared minus 1, g prime of x is equal to 2x. Now dy by dx is therefore equal to f prime of x, which is 1, and since we're multiplying we can just leave that g of x, x squared minus 1, plus g prime of x, 2x times x minus 2. Now since we're not just finding our derivative, we're going to find the equation of the tangent and normal. We can just go ahead and plug in our x value, since we are going to get a numerical value, right? But if you're going to find just the derivative, you will need to simplify, but no need to simplify here, as I said before. So dy by dx is equal to or corresponding x value minus 2 squared minus 1 plus 2 times minus 2 bracket minus 2 times minus 2, not times, sorry, minus 2 minus 2. So we have dy by dx is equal to 4 minus 1 plus minus 4 times minus 4. Minus 2 minus 2 minus 4. So dy by dx is equal to 3 plus 4. Negative 4 times negative 4 will give us a positive 16. So dy by dx is equal to 19. So there we have our gradients. We can now go ahead and find our corresponding y value. So y is equal to x minus 2 x squared minus 1. So when x is equal to minus 2, minus 2, minus 2, minus 2 squared minus 1, we have y is equal to minus 4 times 4 minus 2 squared, that's a positive 4, minus 1, that's 3. So y is therefore equal to negative 12. So when x is equal to minus 2, y is equal to negative 12. Now we can go ahead and find our equation of the tangent. So equation of tangent y equal mx plus c, or y value minus 12 is equal to our gradient 19, or x value minus 2 plus c. So minus 12 equal minus 19 times minus 2 minus 38 plus c. Wow. Now we're going to continue finding the equation of our normal. So equation of normal, remember that the gradient should be equal to the product of the gradient should be equal to minus 1 when they are multiplied. So since this is the gradient of the tangent is 19 and both are perpendicular, we should have our gradient mean equal to negative 1 over 19 for us to get a product of negative 1 when they are multiplied. So remember in the form y is equal to mx plus c, or y value is minus 12 is or gradient minus 1 over 19, x value minus 2 plus c. So minus 12 is equal to 2 over 19 plus c. C is therefore equal to minus 12 minus 2 over 19, which is minus 12 and 2 over 19. So our equation at the normal is y is equal to minus 1 over 19 x minus 12 and 2 over 19. Here we have our final example for today. So feel free to try. Remember your solution is here. So you can go ahead, pause the video. So y is equal to 1 over x, or x is equal to minus 1. Now, since we have our variable here and we have it as our denominator and we're dividing, we can simply bring it up, and it goes to the negative power at which it is at. So we can therefore say that y is equal to x to the minus 1. Now finding dy by dx, we have minus x to the minus 2. So now we can go ahead and find our derivative or gradient, sorry. So minus 1 to the minus 2, so dy by dx minus 1 to the minus 2, that's 1 times minus 1 minus 1. So our gradient is negative 1. Now we're going to find our corresponding y value at which x is equal to minus 1. So y is equal to 1 over minus 1, or y value is therefore negative 1. So when x is equal to minus 1, y is equal to minus 1. So now we're going to find the equation of our tangent. So equation of tangent, we know that it should be in our form y is equal to mx plus c, or y value is minus 1, or gradient there is minus 1, or x value minus 1 plus c. So we have minus 1 is equal to positive 1 plus c, so c is therefore equal to minus 2. So our equation of our tangent is therefore y is equal to our gradient minus x, c minus 2. Now finding the equation of the normal, remember that the normal is perpendicular to the tangent, therefore the product of gradient should be equal to minus 1. Since it is minus 1 here, we know that our gradient in this case would be a positive 1 minus 1 times 1, that gives you a negative 1. Alright, so in the form of y equal mx plus c again, so y minus 1 gradient 1 minus 1 plus c. So minus 1 is equal to minus 1 plus c. C is therefore equal to 0. So our equation of the normal is y equal x. But you should already know that you should have gotten this solution, since we have when x is equal to minus 1, y is also equal to minus 1. From there, you see that one of the lines would be y equal x, because x value corresponds with our y value. Now do have yourselves a blessed day. Yes, have a beautiful one.